stuff.
Every once in a while, a revolutionary product comes along that changes everything.
I'd like to thank you for leaving crazy person out of the description. I thought I'd perhaps tell the story of how I sort of came to be here. How did some of these things happen? And maybe there's some lessons there, because I often find myself wondering, how did this happen? So when I was young, I didn't really know what I was going to do when I got older. Inventing things would be really cool. And the reason I thought that was because I read a quote from Arthur C. Clarke, which said that a sufficiently advanced technology is indistinguishable from magic. And that's really true.
Now, you know, one of the pioneers of our industry, Alan Kay, has had a lot of great quotes throughout the years. And I ran across one of them recently that explains how we look at this, explains why we go about doing things the way we do, because we love software. And here's the quote: "People who are really serious about software should make their own hardware." You know, Alan said this 30 years ago.
High-end sports car, faster than a Ferrari, faster than a Lamborghini. Nothing compared to this.
Every which way I did the numbers, the electric cars were a lot better than everything else.
Tesla is pushing the bounds of what is possible with self-driving.
Does the Elon today, does that look like the Elon you knew in 2003?
I think Elon's Elonness has increased over the years.
No. If you had to describe him in a nutshell.
No. I mean, if you wanted to describe Elon Musk in a nutshell, I don't think he would fit in a nutshell.
So I thought, well, you know, if I can do some of those things, basically if I can advance technology, then that's like magic, and that would be really cool. And I always had sort of a slight existential crisis, because I was trying to figure out what does it all mean? Like, what's the purpose of things? And I came to the conclusion that if we can advance the knowledge of the world, if we can do things that expand the scope and scale of consciousness, then we're better able to ask the right questions and become more enlightened, and that's really the only way forward.
We're trying to dig a hole under LA, and this is to create the beginning of what will hopefully be a 3D network of tunnels to alleviate congestion. So, I mean, right now, think one of the most soul-destroying things is traffic. It affects people in every part of the world. Just to sort of show what we're talking about. So there are a couple of key things that are important in having a 3D tunnel network. First of all, you have to be able to integrate the entrance and exit of the tunnel seamlessly into the fabric of a city. So by having an elevator, sort of a car skate that's on an elevator, you can integrate the entrance and exits to the tunnel network just by using 2 parking spaces. And then the car gets on a skate. There's no speed limit here, so we're designing this to be able to operate at 200 kilometers an hour, about 200 kilometers an hour, or about 130 miles per hour.
Yeah, Elon is complicated. He's real smart and delves into everything, which can be both a positive and a negative. He pushes on certain things in development that you kind of wonder why, and sometimes it makes sense and sometimes it doesn't. And he's very much into risk. He's willing to take on risks, financial risks, for himself personally. And
that was in '95, and that's also when the internet started to happen. And I thought, well, I can either pursue this technology where success may not be one of the possible outcomes, which is always tricky, or participate in the internet and be part of it. So I decided to drop out. Now obviously, fortunately, we're past graduation, so I can't be accused of recommending that to you. Initially, the initial thought was with PayPal was to create an agglomeration of financial services, so to have one place where all of your financial services needs would be seamlessly integrated and work smoothly.
The battle for control of the internet is on, and it's no game. Under attack, Microsoft, the giant corporation whose computer operating systems dominate the entire market. California company that provides online access to information about cities around the country. Everything from where to eat to how to get around.
You imagine the possibilities, but
the company's chief engineer and founder is 27-year-old Elon Musk. And how old were you when you started this company, or what became this company?
23.
It's a classic Silicon Valley story. Before there was the vintage Jaguar, the 6-figure salary, the cute dog, and the nice house to share with the pretty girlfriend, there was the $200 a month office with the leaky roof.
It was just the nastiest place you can imagine.
And you lived in it too?
And I lived in it too, and showered at the YMCA.
Now Musk has his own computer command center, and his business is thriving. To his delight, Microsoft has tried and so far failed to get a hold in Zip2's market.
I thought, well, what are some of the other problems that are likely to most affect the future of humanity? It really wasn't from the perspective of what's the rank-ordered best way to make money, which is okay, but it was really what I think is going to most affect the future of humanity. So I think the biggest terrestrial problem we've got is sustainable energy, but the production and consumption of energy in a sustainable manner. If we don't solve that this century, we're in deep trouble. And then the other one being the extension of life beyond Earth to make life multiplanetary. So that's the basis for. The latter is the basis for SpaceX, and the former is the basis for Tesla and Solar City.
Hi, my name is Franz von Holzhausen. I head up design for Tesla. I've been doing this for about 15 years now. I went up to meet him at SpaceX and was just really impressed with what he was pulling together at that time. This was mid-2008, and so both Tesla and SpaceX were in their infancy and just really getting started. But I just felt like here's a company and a guy incredibly focused on sustainability, trying to do something that no other car company was doing and be 100% electric. And yeah, we connected, and I don't know, the rest is kind of the history that's around us.
What is it like to have Elon Musk as a boss?
Elon's a great boss. I mean, he's always pushing the boundaries, always pushing the limits, and always keeps us trying to be as radical as possible, never accepting the status quo, always trying to take one extra step to make sure something is perfect. He cares a ton about what the customer perception is. How does a customer relate to the product? What's the experience they're going to have? And he cares deeply about that. And so we are constantly worried about that as well and constantly focused on that. So, I mean, he's just, like I said, he's just always pushing us and getting the best out of everybody on the team.
Talk about the Cybertruck design. How did this design come to be?
The Cybertruck is one of these rare moments where, in a way, form followed function. A lot of times we put the form in front of the function, especially in the automotive world, and it's really tough to mix the two. But Cybertruck is really born out of the idea of a different way of manufacturing a material that put the toughness on the outside. So we really wanted to use stainless steel as a material so that the hardest part of the vehicle was on the outside, not the delicate paint. And it felt right for a truck that's used in like a Swiss Army knife in any kind of environment. Has to be tough. So
first of all, let's they talk about how trucks are tough. That's one of the defining characteristics of a truck. So how tough is this truck? Let's find out. So we actually had to come up with a special, ultra-strong, Tesla-designed steel alloy. So this alloy, this metal did not exist before. We needed something that you could actually manufacture, but that would have basically no corrosion, that didn't need paint, but you can still make it in volume. And part of the reason that it has this angular shape is you can't actually stamp these body panels. The body panels would break the stamping machine. Oh, and I should say also, because of the steel exoskeleton, it actually has more torsional rigidity than a sports car. It has more torsional stiffness than a McLaren P1. So that's a big deal. Now you may remember an incident 4 years ago. Didn't quite go as planned. And Franz, maybe we should try it again. So anyway, the glass is tough, basically. That's what we're saying. You don't have to worry about like rocks hitting the glass and cracking the glass. This glass is basically rock-proof. It also makes the car very quiet. So the thing that you'll appreciate when you drive the car is how smooth and quiet it is. It doesn't feel like a normal truck. It's smooth as silk and silent when you drive it. Yeah, so in terms of toughness. And then things like rollover, because the center of gravity is so low, it doesn't roll over. And if you're ever in an argument with another car, you will win. In movies, you sometimes see the hero or heroine hiding behind the car door while being shot with bullets. That doesn't actually work unless you're driving a Cybertruck. So if Al Capone showed up with a Tommy gun and emptied the entire magazine into the car door, you would still be alive. So, you know, and so people say, like, well, you know, why'd you make it bulletproof? I'm like, why not? Do you want to, how tough is your truck? Because the other trucks, the bullets go through both sides. So you shoot a bullet, goes through both sides of the car. You know, you just never know. I mean, sometimes you get these, like, late civilization vibes. You know, you never know when the apocalypse could come along at any moment. And here at Tesla, we have the finest in apocalypse technology.
Stainless steel is really tough to form, especially when you make it bulletproof or thicker to withstand impacts and not be damaged. And so we really looked at new ways of manufacturing it. You could only break form and form it in one direction. You can't do compound curves or things with the thickness of the stainless steel that we're using. So it really led us to a design that was really planar, really simplistic, and was also a chance to break the paradigm of what pickup trucks have been for the past 60 or 70 years. They're the same. There's kind of this three-box shape. And we just thought from an aerodynamic perspective, having a covered back, a sloping roof would also be helpful. And oddly enough, you may not look it, but the Cybertruck is an incredibly aerodynamic vehicle.
How different will the production Cybertruck be from this vehicle behind you? And also, what's taking so long to get it off the production line?
There's a lot of new things in Cybertruck. When we're reinventing a product, sometimes we have to go through these processes just to prove it out. We had this idea that making an exoskeleton vehicle could work, and so we've been using that time to make sure that that actually is working. And the Cybertruck will look, for all intents and purposes, just like the one behind us. It's maybe slightly smaller, a few percentages, but in general, this is what the truck will look like. There was a moment, you know, where I thought when I first joined Tesla that it would be great to see multiple Teslas in one drive experience around town, and now, you know, it's hard to go anywhere without seeing a bunch of Teslas. So it's great to see the impact that Tesla's had in people's lives, but also how it's changed the industry and really push this idea that an EV can be better than an internal combustion vehicle. And Cybertruck will continue that story.
Yeah, I mean, this is our biggest product release in quite a while. I mean, the Cybertruck is our, you know, probably our most revolutionary product. So for it to actually reach production and to deliver the first production articles to people, you know, which means it's passed all of the regulatory tests and is reliable and something that can be out there on the roads was extremely difficult. I've often said that you know, prototypes are easy, production is hard. You know, with a small team, you can make a prototype of almost anything in maybe six months with 100 people. But to actually create a production system, you need 10,000 people and 2 years or 3 years.
Yeah. Made in Texas. First started out Tesla, I thought maybe we had optimistically a 10% chance of succeeding. And here we are today. Damn. We're really entering a new phase of Tesla's future and scaling to extreme size. As you can see from this building, it's not small. This is the machine that builds the machine. The factory is the product. Relative to production, prototypes are easy. Production is hard. And this building is the most advanced car factory that Earth has ever seen. And now, let us deliver our first Tesla cars made in Texas. Well, actually, 2 or 3 years. Most people can't even do that. So, and I may not know this, but I tag Tesla as working at the speed of thought, not like what everybody else does, you know, committees and whatnot. You guys seem to be able to spot something that should be done, and maybe other people have spotted it as well, but you actually get it done. And that's where like self-driving. I'm really, I've driven it. I'm very impressed with that. 48 volts. I mean,
it's been a long time that it's been at 12 volts, far too long.
Yeah, 60 years.
Yeah.
So I've got a question for you. How difficult was it to move from 12 to 48? Because I know when the S came out,
yeah,
I wasn't, or the Plaid came out, I wasn't happy. I thought you were going to do it on that. I was looking for that big giant weight reduction and cutting all the wire and whatnot. But this one, you've got it in. So how difficult was it to get that to happen?
Well, it's very difficult to change the bus voltage from 12 to 48 because all of the peripheral items, everything that connects to it has to interface at 48 volts, or you've got to step down to 12 volts.
Yeah.
So, you know, there are hundreds of things that interface to the low voltage bus, and that's everything from, you know, the electronics in the car, the window, the window motor, the airbags, the you know, the thing, the seat adjustment mode, everything is set. The headlamps, everything's set to 12 volts. So the entire supply chain, the entire design infrastructure is set for 12 volts. This is why it's been stuck at this absurdly low number for a long time. And I think, so you want to raise the voltage in order to lower the current, thus lower the heating in the wire. And the net effect being that you can have much thinner wires. Then as you raise the voltage, you can drop the thickness of the wire. So you can use much less, in a nutshell, you can use much less copper, and the wire harness weighs much less as you raise the voltage.
And taking a chance and being bold, but still being safe and functional and hitting all the attributes for what a pickup truck should be. And there's no reason why you can't change the recipe.
Special moments. But these things are rare. It's very rare that a product comes along that is seemingly impossible, that people said was impossible, that experts said was impossible. And this is one of those times. We have a car here that experts said was impossible, that experts said would never be made. That it really is the most, I think it's our best product. I think it's the most unique thing on the road. And finally, the future will look like the future. So.
There are a lot of unique features on Teslas, like the door handles, for example. Why does Tesla decide to push the boundaries on small features like that?
Some of these small features, like the door handles, are just really great first touch points. But the handle is the thing that greets you when you approach the car. And so to have the handle come out magically as you approach it and give you your first kind of handshake really gave a slight anthropomorphic feel to the car. Just humanized it a little bit, allowed you to not just be stepping into a really cold machine. It was a warming gesture. And it's also very aerodynamic to not have door handles hanging out in the wind on the side of the car. So we combine those kind of things. Tesla isn't beholden to what's been done in the past, and we're always trying to push the boundaries and deliver on a promise of something fun, something enjoyable, and something that you would love to own and tell your friends about.
This is a self-propelled sled. It pulls itself backwards. This weighs about 35,000 pounds. As the box moves forward, it increases the weight onto the pan, which is here on the ground, causing the driver to go no further.
The sled will always win. It's got so much weight behind it. The mark of success here is as far forward along the track as you can get. Today we've got a couple vehicles here. Having the vehicles fully charged matters because that's when you have your peak power. Making sure they're all fully charged really gets us on the same playing field. We wanted to bring not just an EV competitor, so we also looked at what is a great internal combustion engine vehicle that's got huge towing capacity and great capability. Tractive power is really how much can you get that power from the motor to the ground. Truck pull is a showcase of power and tractive power of the truck, and that translates directly to on-the-road towing, towing your boat, towing your payload. What we've designed the truck to be is like really comfortable, really stable, really powerful at high payloads, and that gives you the ability to be confident on road. In order to make this a really apples-to-apples comparison, we're running them as they come straight from the factory, so stock tires, they're running at a curb weight plus driver. A heavier truck in this kind of event will typically give you more momentum with the truck itself. So coming in here with a truck that's one of the lightest in this group, if not the lightest, and out-pulling everybody else, really says something about the capabilities of the vehicle.
So when I think like what is the fundamental good of a company like Tesla, I would say hopefully it does. If it accelerated that by a decade, potentially more than a decade, that would be quite a good thing to occur. That's what I consider to be the fundamental sort of aspirational good of Tesla. If you look at the progress in space, in 1969 we were able to send somebody to the moon. 1969. Then we had the space shuttle. The space shuttle could only take people to low Earth orbit. Then the space shuttle retired, and the United States could take no one to orbit. So that's the trend. The trend is like down to nothing. This is not. People are mistaken when they think that technology just automatically improves. It does not automatically improve. It only improves if a lot of people work very hard to make it better. And actually, it will, I think, by itself degrade, actually. You look at great civilizations like ancient Egypt, and they're able to make the pyramids, and they forgot how to do that. And the Romans, they built these incredible aqueducts. They forgot how to do it.
Mark there. The first launch, I was picking up bits of rocket near the launch site. It was a bit sad. But we learned with each successive flight, and we're able to, eventually with the fourth flight in 2008, reach orbit. And that was also with the last bit of money that we had. So thank goodness that happened. I think the saying is fourth time's the charm. So we got the Falcon 1 to orbit, and then began to scale that up to the Falcon 9, which is about an order of magnitude more thrust. It's around 1 million pounds of thrust, and we managed to get that to orbit, and then developed a Dragon spacecraft, which recently was able to dock and return to Earth from the space station. That was thanks. That was a white-knuckled event.